So you guys should be on your 4-7 notes. And we're going to flip to example 2. Yesterday, we learned about taking a number that was written in scientific notation and converting it to standard notation. Today, we're going to do the exact opposite. We are going to take a number that is written in standard notation, which is our general way of writing it, and we're going to convert it to scientific notation. So I want to take a look at this first number right here. That's a really small decimal that we have. If we want to write a number in scientific notation, our first factor has to be greater than or equal to 1, but less than 10. So I have to take this number right here, and I have to create a number between 1 and 10. Raise your hand if you ignore the decimal point, if you can see a number that's between 1 and 10 that we could create from this right here. Raise your hand, raise your hand, raise your hand. If you see a number that's between 1 and 10. 9. Very good. So what we're going to do is we're going to go ahead and write our first factor is a 9 right there. And essentially what we did is we took and put a decimal after that 9 right there. We moved that decimal point from all the way over here on the left, and we placed it after that 9. Now, we don't really need to write it, but I'm going to go ahead and write times 10 to the, and then I have to decide what my power is going to be. In order to determine my power, I want to take a look. I moved my decimal after the 9, and I want to ask myself, where do I have to move that decimal to put it back to where it originally started? So let's start with the direction. What direction would I have to go to move it back? Left or right? We have to go to the left, right? If you go to the left on a number line, is that positive or negative? Negative, so it's going to be a negative exponent. So put the negative exponent. Because if we have to move that decimal to the left to put it back, it's going to be negative. And now let's go ahead and count how many spaces we moved it. 1, 2, 3, 4, 5, 6. So you guys counting 6 loops? So it's going to be 10 to the negative 6th power. So you just took standard notation and wrote it as scientific notation. We're going to do another one. So now I want you guys to take a look at this box, the we do box right here. Raise your hand if you see a number that we could create that's between 1 and 10. It's got to be greater than or equal to 1, but less than 10. Raise your hand if you see something. 5 would work, but we have to also, let me rephrase my question. We can't get rid of the 1 or the 5. We can drop off the zeros, but we have to keep both the 1 and the 5. So using both the 1 and the 5, how could we create a number between 1 and 10? Very good. Go ahead and write 1.5. You're exactly right. 1.5 is greater than or equal to 1, and it's less than 10. So we are placing that decimal between the 1 and the 5. Then I'm going to write times 10 to the. Now, my decimal is between the 1 and the 5, so go ahead and place it there up here. And we have to ask ourselves, where would we move that decimal to place it back to where we originally were? So the first thing is, are we going to move to the left or to the right? We're going to move it to the right, right? If we go to the right on a number line, is that positive or negative? It's positive number, so it's going to be positive. Now let's count our spaces. So go ahead and make your loops. 1, 2, 3, 4, 5, 6. I got 6. Did you guys get 6? So that would be 1.5 times 10 to the 6th power. Wherever you placed it. So we placed the decimal between the 1 and the 5. So while you're passing, go. Let's go. We're going to do a couple more together. Go ahead. No, it's got to be 1.5 because the 1 comes before the 5. Good question. All right, so do me a favor. Flip to your 4-7 worksheet, and I want to do a couple more of those with you guys because I don't think 2 examples is quite enough for you. So flip to this worksheet. And let's look at number 1. We're going to do number 1 and number 4 together. So for number 1, using the 1, the 2, and the 5, who can raise their hand and create a number between 1 and 10 for me? Greater than or equal to 1, less than 10. And you have to use the 1, the 2, and the 5 in that order. Very 1.2. What comes after the 2? 5. Very good. 1.25. Go and write this down, okay? You got it already? All right. So we're going to change that to 1.25 times 10 to the. And now we placed our decimal between the 1 and the 2. So we need to ask ourselves, where would we move that decimal to send it back to where it originally was? Well, are we going to go left or right? We're going to go to the right. Let's go ahead and count 1, 2, 3 spaces. So since we're going to the right, is it positive or negative? Good, and it's going to be a positive 3. So go ahead and try number 4 on your own form. Yep, try number 4. So your first step is to create a number between 1 and 10. So you want a number greater than or equal to 1, but less than 10. What number did you make, bud? I love it, 5.8. That's perfect. Go ahead and finish it from there. And who can raise their hand and help me out with the power? Raise your hand if you can help me with that power. 5.8 is perfect. Okay, so we've got a base of 10. And what's the little tiny exponent? Go ahead. A 4, good. So it's 4 spaces. Now we have to see, did we move to the left or to the right? We moved to the left, right? So is going to the left positive or negative? Negative. So it's going to be a negative 4. Yes, sir. Go ahead. Yeah, just go ahead and go. Any questions on that? You guys feel okay to do that? All right, let's take a look at our last example then. You on this page here, bud? All right, so example 3, we're still working. What's that? I can't hear you, bud. We're going to do the top 2 first, okay? So we need to order these numbers from least to greatest. My personal preference when I'm ordering these numbers from least to greatest is to actually switch these out of scientific notation. So what I'm going to do is I'm going to start with this 2.4 times 10 to the 5th power. And how many places am I moving my decimal for that one? 5 spaces. In which direction? To the right, because it's positive, right? So let's take 2.4, and we're going to move our decimal 1, 2, 3, 4, 5 to the right. And that's 1, 2, 3, 4 zeros. So that number just became 240,000. So I'm going to write that right above it. 240,000. Now let's do the same thing with this 3.1 times 10 to the 5th power. We've got 3.1. And what direction am I moving my decimal? Go ahead. If it's positive, move it to the right. Very good. And how many spaces? 5. Let's go 5 spaces to the right. 1, 2, 3, 4, 5. And I'm going to put 4 zeros there. So I'm getting 310,000. So I'm going to write that right above it as well. And then that last number is simply what? 2,400 or 2,400, you could say. So we're going to write 2,400. So now we need to order these from least to greatest. We can totally do this. Who can raise their hand and tell me my smallest number? Of those 3 numbers that I've written, which is the absolute smallest? Go ahead. Good. 2,400. So I'm going to write 2,400. And then I'm going to cross that off because I already used it. After 2,400, who can raise their hand and tell me my next smallest number? What's the next smallest? 240,000. Good. But we want to write it as its original number. So let's write the scientific version of that, which is 2.4 times 10 to the 5th power. So right away, we're converting it back to the original. And I'm just separating them by a semicolon here. So which is my biggest number? What's my biggest number? 3.1 times 10 to the 5th power. Excellent. Always convert them back to the original. I'm going to start a second video here. Quick, go ahead and try that next one on your own for me right now.